We have already started to learn C#. We have learned about methods and we have learned about variables. You have even completed a challenge in which you added another 3 methods, each of which will subtract, multiply, or divide 2 values. 2 values that are being currently used as class level variables. In this lecture, we're going to talk about classes and namespaces. If you have paid attention, we've already been using classes. If you didn't know what a class is, in this lecture you're going to learn about them. We're going to be creating our own, but in fact we have already been using classes as we have moved forward into the course. For example, on the Xamarin projects that we created, we had the app class, the main page class. We created our own classes. In this console application, we have the program class and we have been using the console class. Now let's create our own classes and familiarize ourselves with the concepts bound to classes and start using them. For doing that, I am going to create a new console project. And you can do it in the same solution that we created before, so you have all of the C# section projects inside of one solution. And to add a new project to a solution, you go to the Solution Explorer, right-click on the solution, select Add, and select New Project. In the Add New Project window, find the console app template, and this is going to be called C# section _2. And we're going to click on OK. It is in this program, in this new console application, in which we're going to take a look at classes in a bit more detail. Right now we already have by default the program class, and inside of it we have one of its members. In this case, the main method. So this is the basic structure of a class. You will have its definition and its body. And in its body you can have as many members as you need. And you can think as members as all of the methods that it's going to have and all of the variables that it's going to have, among other things that we are not going to be covering right now, but mainly any element that is defined inside of the body of a class can be called its member. Now let's define our own class and start using it. We can define a new class in the same file, and we can even define classes inside of the same class. Right now though, I want to define a new class outside of this class, but still inside of this namespace. Now, talking about namespaces, notice that the class is inside of a namespace that is also first defined and then we have its body. The namespace is going to be, like its name suggests, a space or a container or a group of elements that can be easily referenced between them. And we're going to take a look at what I mean by easily referenced between them. Let's first define a new class. This class is going to be called Simple Math, for example. And then we can define its body inside of these brackets. And the Simple Math class is only going to contain 4 members. And these 4 members are the methods that will allow the user to add, subtract, divide, and multiply. These methods are going to be very similar to the ones that we have in the other program class that we defined in the previous project. But these are going to be a little bit different because we are no longer going to be using class level variables. We need to receive the variables with which the operations are going to be executed right from the methods. So let's define our first method. Now, previously we defined the methods as private, but remember that private means that the member can only be used within the class. And now we want to use those methods outside of the class, for example, inside of the program class. So we would need to define them as public. This will allow anyone with access to this class to be able to use these methods. So we are going to define them as public. They are going to be integers, and the first one is going to be add. It's going to receive a number 1 as integer. In fact, since we already learned about floats, let's make this floats. It's going to receive number 1 and it's going to receive number 2. And because we're going to be operating with floats, we need to return a float as well. And inside the body, we're going to return the addition of number 1 plus number 2. And we can quickly define the other 4 methods that we need, which is the subtract first, that returns n1 minus n2, the multiplication that returns n1 times n2, and the division that returns n1 divided by n2. And we have the first 4 members of our simple math class. And to be able to use them, we will have to go to the main method. Now remember that in the previous lectures, we mentioned that this method had to be static because nothing is created previously. Well, we are not yet going to be creating anything. So if I were to access the simple math class, which I can access by just writing it, and I write dot, notice that no add or subtract or multiply method is listed. This is because we haven't created any instances of the simple math class. We're going to be creating instances of a class in a couple of minutes. By now, let's just define these methods as static. So we check out the difference and we may understand a little bit better what this static keyword does. The static keyword has to be added between the access modifier and the type of the method. And once we have defined every single method as static, we can return to the main method inside of the program class, start writing simple math, then type dot, and notice that we now have access to the subtract, the multiplication, the division, and the add. And so we can call, for example, the division and pass a couple of floats as arguments. And to be able to define floats, you need to add an f at the end of the definition. And so we have a float that is 432.23 and defined as float with the f. And we could, for example, display them into the console through the writeLine method that we have inside of the console class. And in the case of Windows, it's going to be very important that we add a call to the readLine method from the console class, so the program doesn't end. So notice that we had to add static to be able to use these methods. What static made is that it removed the necessity of us to create an instance of the simple class for us to be able to use these methods. And that is exactly the functionality that we needed for the simple math class. We should be able to use these methods without the need of an instance to be created, because there is no real need for an instance in this case. We can just add and subtract and multiply without the need of anything else. But we're going to take a look in just a minute as in a scenario when it is needed to create an instance, and so the members wouldn't have to be static. Before doing that, let's go ahead and test our application. To test it, the first thing that you have to do is change the project that you're going to be executing. It's probably still defined to the previous project as default. You can either go to the Solution Explorer, right-click on the new project and select Set as a Startup Project, or you can change it directly from this drop menu and then click on Start. Notice that the division is being performed of 432 divided by 54,523, and we have the result in here. We see decimal values because this is a float variable. And so we are now able to use these methods from another class. But let's create another class so we can take a look at when is it needed for us to create an instance of it, and we will also take a look at namespaces. What I want to do is go to my new project inside of the Solution Explorer, right-click on it, and add a new folder. This folder is going to be called Classes. And then inside of the Classes folder, I am going to add a new class. The first class that I will add to the Classes folder is going to be called Bank Account. And I can click on Add, and it is going to be added. And it already has its body, and we can start defining members. But notice something before. Notice the namespace. The namespace is now the name of our project, dot, and the name of the folder in which it is defined. If you go to the program file, you can see that the namespace is only the name of the project, because it is defined in the root of the project. But because the bank account class is now defined inside of another folder, the name of that folder has been added to the name of the namespace. And remember that namespaces are groups that allow members of the namespace to be easily referenced between each other. And let's take a look at what I mean by reference between each other. This namespace, you may agree, is different than this namespace. So these are two different groups. And these two classes inside of the first namespace can easily reference each other because they are inside of the same group. We didn't need anything else to be able to use the simple math class. But let's try inside of the main method to call the bank account. Notice that there is nothing available in this list that is called bank account. Now, there are two reasons why this is happening. First, on C#, the default access modifier is private. That means that when we do not define an access modifier for classes or for methods or for variables, the default access modifier is private. In the case of a class, it would mean that it is only available inside of the same namespace in which it is defined. So we can change the definition to public, and it should now be accessible outside of the namespace in which it is defined. But if we head back to the program and we go to the main method and we start writing bank account, it is still not there. And that is the second reason. The second reason is that it is in a different namespace, and currently the file program.cs does not know that a C#section_2.classes namespace exists. So we need to tell it that it exists. And we can do it by writing a using directive at the top of the file. Notice that there are already some using directives here. These directives are going to tell the file about other namespaces that it can start using. And so, for example, I can start writing using, write C#section_2 dot, and notice that the classes namespace appears right there. And now with this using directive defined, the program.c# file knows about this namespace, and I can start typing bank account, and now it is accessible. You may notice that there are some namespaces that are grayed out. Those namespaces are the ones that are not being used, meaning that we are not really using any members from inside of them, but the ones that are in black are the ones that we're already using. Notice that since I wrote bank account down, it has turned black, and if I delete it, it turns gray again. We have taken a brief look at classes and namespaces, but there is still one question unanswered, and that is, when is it needed to create an instance of a class? We are going to take a look at that unanswered question in the next lecture.